Right, so if you've been following along with the lectures, we saw tuples, which are sequences of elements that are immutable, meaning once you have that sequence, you cannot change it. Um, the next structure that we looked at was a full-out list in Python. In Python, a list is very similar to tuples in that you can hold any different types, any objects or any series of objects, but you can modify lists. So in this exercise, we're going to build a list and then call a function called remove duplicates, or we're going to build a function called remove duplicates. The remove duplicates function will accept a list and then modify it such that all the duplicates within it are removed. And I kind of gave you a hint here. The easiest way to do this is actually to create a second list within that function and incrementally build out a list of all of the original elements, making sure not to add anything that's already there. And then before returning, just swapping, right? Switching the original collection for the new one. So remove duplicates in this case won't return anything. It's not going to return a new list. It's just going to modify the existing list that was passed in as a parameter. So let's start by creating a test series. And I'm going to call remove duplicates and on my test. And so let's just print them out. We can also sort of, create a test. So if, or I could do, if length of test and how many unique numbers we've got 1, 2, 3, 4, 5. That's it. So there's 5 numbers. Not equal to 5. Um, test failed. That's not the only reasons our test would fail, right? I'd have to check to see whether 2 is in it, 1 is in it, 2 is in it, 3 is in it, and all that kind of stuff too. So I could also write a test that says for I in test and check all these numbers, but the problem, this gets kind of awkward because test is actually going to be changed. So I can't really, I was going to say, look at every number in test and make sure it's still in test. That gets a little more cumbersome. So I'm going to leave it like this for now. All right, so remove duplicates. We'll call this collection. So the hint that I provided in the example text was to create a new list. So I'll call that uniques. And I'm going to start it off as empty. And I'm going to go for every value in the collection. And I'm going to say if this value is not in uniques already, then put it in uniques. And we saw that the append function can add it. And if it is in uniques, just ignore it, don't do anything. Okay, so now uniques would hold all the unique values, but the question is, well, we want collection to only have the unique values. So maybe the most, kind of intuitive way of doing this is just say collections equal uniques. But if we run this, we'll see that the test fails. And the reason why the test fails is because, well, first of all, we don't have 5 elements, we've got a lot more. We have actually the original thing left. I want to kind of investigate that and see, well, why is that, right? Did this code not work? Let me do print uniques. And you see when I print uniques, it's actually the numbers that I thought I should have. If I print collection, it's still the numbers I should have. So the question is, well, what's happening? Why do I have the right values here? But then when I come back here, when I assign the parameter to a different list, why didn't it work? And to answer that, you have to have a good grounding in how memory is working and how things are being passed into functions. So let's look at memory. Right? So I kind of forget what the numbers were. Well, there were 1, 2, 2, 3, 4, 4, 5, 1, 2, 3, and I don't remember what all of them were, but there's your list that is initially populated. So here's my test. And let me move this so I can see everything. Okay. All right, so I've gone through and now I've called test and I've called remove duplicates with test being passed into the function. All that's done is it's created another variable called collection that also points to that object. And I've created another unique list that points to a new list. And of course, when we're all done, it has 2, 3, 4, and 5 in it. Then when I say collection equals unique, I'm just moving collection to point over here. But what's important to notice is that test has been unaltered, right? Test is still pointing to the original list. This arrow is gone, but that doesn't mean the initial list has changed. Right? So saying collection equals list or unique just simply changes the parameter variable. And that's why I'm seeing the initial test still print out here. All right, so how do we fix this? Well, we really do need to actually delete everything in this list. What we really want to do is we want to, let's see if I can do this. We want to actually wipe out everything in the original list collection. All right, and we'll have, actually, we want to have collection still point to that. And then we want to copy or put in, append. And actually we'll use a function called extend instead, which will append multiple values to that list. And we actually want to put these new values in there. Okay. So how do we delete things out of a list? It's actually a pretty straightforward process. We can delete a unique element or a specific element out of collection, right? If we did collection 0, for instance, like that, it would delete or remove the first value from collection. If we did this, it would delete every element through the first 5 elements of this collection. This is just standard array syntax, right? This the array slicing. And if we want to do the whole thing, we can just do something really simple like this. Delete everything from 0 all the way to the end of the list. Once we delete everything out of collection, then we can say collection.extend. And if you look in the textbook, and again, this is where we start to talk a lot about your ability to read documentation. The data structures available in Python, functions available in Python are huge, and we're not covering anywhere near all of them. But you should be able to use them. You should be able to make use of them when you need to. So it might be as simple as Googling, how do I add multiple things to a list at the same time? Turns out that the extend function can take another list, I'll call it uniques, and what this function does is it takes all the things in uniques and applies it or appends it to collections. All right, so let's run this now. Now we see that it has indeed worked. Collection has been modified, and we've got the right list. And we can go through and we can remove this. By the way, using that syntax, we might want to actually now go through and do our test case. We can do, let's say, original equals test, and we're just copying a slice of this. And now we could do something like for I in original, if I not in test, print, something in original isn't in final. And that's how I would do that full test case that I was talking about earlier. I don't really, this creating a complete distinct copy of the list, it's a little wasteful, but that should work too. And obviously visually we can see that it was working, but it's kind of nice to have a program to test that as well.